This is homework 8. I would have to say this is probably the most important homework that we have in this course. As far as your ability to continue to do other things, solving equations are going to be a really big part. Over here I've written down the rules in very shorthand form. We have to do them legally and do them smartly, but we're going to get rid of the parentheses if there are any. We're going to combine like terms if there are any on each side. And then after that, we're going to get rid of the worst x bank balance. We're going to get rid of the coefficient of x. X will equal something on one side because we've gotten rid of its coefficient. We'll say x. The other side will be the expression that we simplified. We'll get that number and we'll check it in the original equation. So let's get started. Number 1. 4y plus 9 equals 5. What do we do here? Well, no parentheses, no like terms, y in a number, just a number. Let's get it so that the y term is on its side by itself and the number term is on the other side. We'll actually leave 4y exactly as it is, and we'll say we've got our 4y plus 9 equals 5. We'll subtract 9 or add negative 9 to each side. This will be gone and 0 and not written, and we have 4y equals 5 plus negative 9, subtract for 4, strong on the negative. We're almost there. We've now done step 3 because we have y's on one side and numbers on the other. That's what happens when you get rid of the worst bank balance for x, and you get the other numbers on the other side. Now we're going to divide both sides by 4 to see what y comes out to be. Y equals negative 1. We're going to go over here and we're going to see if that actually wants to work for us. Actually, I'll do it down here. We've got 4 times our number of negative 1, which I put in parentheses, plus 9. We want the whole thing to equal 5, so we're hopeful. We have negative 4 plus 9. Negative 4 plus 9, subtract and get 5, strong on the positive. It's there. That is perfect. 1 is done. It's a very classic example of how people introduce the work on multi-step equations. Number 2 is another multi-step equation. The one that I'm looking at here is 5y plus 14 equals negative 16. The work we do with arithmetic, you can do on a calculator. You know, when you have trouble with the negatives, you can use your calculator to cover that weakness, but you've got to know what to do with the algebra here. The only y we have is here, positive 5y. There's a number 14. There's a negative 16. There's no parentheses. There's no like terms on this side. There's no more than one term on that side, so there's no like term issue. We go to get rid of the worst bank balance. 5y is good, so we're going to leave it as it is. And what that now means is we've got to get the 14 away from the 5y. To do that, instead of plus 14y, we need to have negative 14y. Negative 14, sorry. Negative 14, leave the 5y. We will scratch out 14 plus negative 14, leaving nothing but 5y over here. Here we have 16 and 14 to add to get 30, right, because they work together. And now the strong sign is negative, so we have 5y equals negative 30. We're going to divide both sides. We're going to divide by the coefficient to get rid of it in this case, instead of using a reciprocal, which comes up with fractions. We're going to divide by 5. And this is 1y. 5 over 5 makes 1. We have nothing but y. Negative 30 over 5 is going to get me negative 6 over 1, which is negative 6. What we're going to do here is take our 5, insert our negative 6, plus 14, and see what we get. Negative 30 plus 14. They're hoping it equals negative 16. Now, when we do this, we have our 30 minus 14 as they work against each other, 20 and 10. We got 6 and we get 1, so we do get a 16. Strong on the negative, we get negative 16, and our solution is correct. Number 3 gets into that worst bank balance stuff, so let's take a look at number 3, which says 3u plus 24 equals 2u minus 11, or dash 11. I'll insert that as this, 3u plus 24 equals 2u plus negative 11. The plus really cuts it loose for what's about to go on with some of the values we're working with. 3u or 2u? Would you rather have $3 million or $2 million? $2 million is worse. Even though it's good, it's worse. We're going to get rid of the 2u. We do subtraction of 2u, which causes a scratch out on one side and reduction to 1u on the other. The key to this concept is understanding that we have the u's on the left side. Our u's are only on the left side. Only u's can be on the left side. So we're going to have to subtract 24, or take away 24 on each side. So now this scratch out, when this works with a full house, back, it's got the full 4 terms, 2 on each side, should get a scratch out on each side. This leaves me with the u over here, and this tells me to go with negative 11 plus negative 24. So I got my 24 and my 11 working together for 35. So over here I get 35. The stronger term from the negative 11 plus negative 24 is negative, so I'm going to divide by the 1, and I'll see that u equals negative 35. Therefore, when I put in my 3 times my number of negative 35 plus 24, I get negative 105 plus 24, 105, negative and positive, so I do 24, take it off, I'm going to get 81 strong on the negative. On the other side, I have 2 times my number minus 11. My number is negative 35, so 2 times 35 is 70 with a negative plus a negative 11. They add together because they work together and get me 81. Strong on the negative like the 70, and I got that. Answer u is negative 35 because the original hit the same target when I put negative 35 in for u in all places. 4. Negative 3y minus 17 equals negative 33 minus y. Now I got some work to do here just setting it up, so I'll write it again. It's dash 3y dash 17 equals dash 33 dash y. In front of that last y, between the dash and the y, I want to put a 1. And in front of each minus, each pure minus, I got negative 3y plus negative 17 instead of minus 17. I have negative 33 plus negative 1y instead of minus 1y. Now, here's the situation where this really starts to work well for us. When negatives come in, the lower, the deeper you are in the hole, the worse that is. Here's someone who owes $3 million. Here's someone who owes $1 million. Both are bad. Which is the worst? Owing $3 million. That's got to go out. So minus 3y, or negative 3y in this case, is worse than negative 1y. And we're going to get rid of that by adding 3y to both sides. That will start the problem for us. Start solving the problem for us. This is gone. 2y shows up on the right side. The key to this concept is, in this case, my y's are only on the right side, and only my y's can be on the right side. This cannot stay. Therefore, the opposite of negative 33 is to go with plus or positive 33. Positive 33. And that causes a scratch out of this. Now on the right side, I still have the 2y that showed up over there only. And now I have 33 minus 17. I got to turn it to 20. And 13 minus 7, if you know it's 6. Or give me 3 more here and 3 more there to get 6. 2 minus 1 is going to get me that 1. 16. Positive. It turns out they're both positive, and that's fine. And now what is my interference? Is the multiplying by 2. I'm going to divide each side by 2. I'll rewrite that 16 equals 2y. I have no problem with the 2y being on the right-hand side, nor should you. If you do right now, it's something to work on getting past. Divide by 2, divide by 2, and all of a sudden y equals 8. I think that y equals 8 is my answer. Now we'll come over here and we'll go negative 3 minus 17. And my number was 8. So I've got negative 24 and negative 17. They're working together to get me to 24 and 17. Get me 41 when I add them together because they work together. Strong on the negative like that. 24 was negative. Now on the other side, I have negative 33 minus, and here comes my number 8. Now, my 8 should be in parentheses so I can free it up with the 1. What do we got now? Negative 33, negative 8. They're being added. That is negative 3 minus 8, negative 3 plus negative 33 plus 8 8, so I take my 33 and my 8, I add them together, I get 41. 41 negative, they did it. They each hit negative 41. Answer for that one is 8. So you're now getting to see some of the benefits of having the concept in mind of when we're trying to get y's on one side and numbers on the other, let's go for that, getting rid of the worst bank balance for y, or whatever letter it is that we're dealing with for our variable. Getting rid of the worst y will create a positive coefficient for y on one of the two sides. The numbers will need to show up on the other side, and then we'll have something that's just a coefficient away from knowing the solution. Here we go. 5. 4 plus 13v equals negative 8v plus 4. We'll do what we're supposed to do. 13v or negative 8v. Negative is worse than positive for your bank balance. That's what's got to go out. So we'll write again 4 plus 13v is negative 8v plus 4. I'm going to get rid of the negative 8v with positive 8v. So this will be gone. And now this will be 21v. This cannot stay. What's happened here is the v's have claimed the left side, so v's can only be on the left side and only v's can be on the left side. I'm going to subtract 4 here, and I'm going to subtract 4 there. This turns out that the 4 minus 4 is going to be gone and leave me with nothing but 21v. And this 4 plus negative 4 is going to be the only thing showing up on that side. So I can't say scratch it and now there's nothing. There's no such thing as nothing in math. Right? Does that mean 0? Does it mean the null set? Does it mean a black hole? We got to see. If we've got to have something to work with, 4 plus negative 4 will give me the number 0. 24v equals 0, and some people will be a little nervous, like, uh-oh, 0, that's not right, that can't happen. 0 and 1 have rights in my classroom, equal rights. Under the law in my classroom, 21v equals target of 0 interference of 21 times v. What do we have to do? To get the v alone, we need 1v. We've got to divide by 21. Even if you use your calculator to confirm this, it may look like your calculator is not working, but this gets me to v equals, and 0 divided by 21 is 0. Looks like 0 is what this wants to have for its v. 4 plus 13, and give me my 0. It's not 130. It's that. 4 plus 0, 4. It looks like the target is 4. On this side, negative 8, give me my 0, plus 4. That's also not negative 80. That's 0, plus 4. That's 4. The targets match. E is 0. 0 is a possible answer. 0 is a number. It has rights. And it's going to, it knows its rights too. 6. Here comes something with like terms. 8u minus 7u plus 2 equals 10 minus 3. Solve it. 8u dash 7u plus 2 equals 10 dash 3. I would hear minuses twice here. I hear 8u minus, so I'm going to go 8u plus negative 7u plus 2 equals 10. I would hear minus, so I go plus negative 3. Looking for like terms. What I do here traditionally is say, don't even look at that side, don't try to cancel anything out, just get the like terms going here. 8u plus negative 7u plus 2. I heard 2u terms, let's bring the negative 7u over here. Okay, let's look at the other side. 10 plus negative 3, both are numbers, let's bring the negative 3 over under the 10. Now let's see what the survivors are when we get this done. 8 minus 7 is 1u, that's been used, plus 2 equals 10 minus 3, 10 plus negative 3 is 7. We now have this as u plus 2 equals 7. 1u is u, so we're closer to the answer than we normally would be. Subtract 2, u equals 5. Let's go see. 8 times my number, not 85, it's 8 times 5, minus 7 times my number, not 75, 7 times 5, plus 2. That's 40, plus negative 35, I'm sure we're used to this being blue. 40 plus negative 35 plus 2. If I stick to what I've been saying, and I will, let's swap the 35 and the 2 for positions. 40 plus 2 plus negative 35. That gets me 42 plus negative 35, and I only have to subtract once. They don't work together, but I got 42 minus 35. That becomes 30 and 12 minus 5. 5 more each gets me a 7. Positive 7 seems to be the target. Other side. 10 minus 3. Do the work on 10 minus 3, you get 7. And they neither one knew they were 7 until some work was done. The work on the right wasn't very much. A lot of work on the left. Target of 7. They both hit it. Both hitting the same target means you have found the solution. Even if you don't know initially what the target is, the goal of finding a solution is to have each expression evaluate to the same number when it's reduced. That's the target, which we may not know till the very end. And we didn't know our target was 7 till we got here. We went and did that and found out that, hey, they did match up just great. So this is how these problems go, and if you do each problem and if you practice it more times than once and so forth, you can get the flow of how this works, but not in a way like, oh, I hope it's exactly the kind of problem that he showed me in class, but rather that you've developed a full scenario of a full batch of processes to go through problems like this. Why? Because we've got 6h minus 5 minus 10h equals negative 21. At least I can see the target here is negative 21. But this is 6h dash 5 dash 10h equals dash 21. Call. 6h minus 5, call plus negative 5. Minus 10h plus negative 10h equals negative 21. Those are okay. Don't look at the negative 21. I'm not worried about that just yet. 6h plus negative 5 plus negative 10h. Bring the negative 10h under the 6h. And over here, all I have is one term, negative 21. So now I have 6h minus 10h. That's going to be 10 and 6 subtracting to get 4. Stronger on the negative like the 10. H, keep the label, plus negative 5 equals negative 21. Now, I have a situation here where I have a negative 4h, and I don't like that. So what I'm going to do is I'm going to introduce how I get away from the negative coefficient. I'm going to bring over here plus 0h because it doesn't have any h's. But 0 is better than negative 4. So that has negative 4h, that has 0 h's, which is 0, and that's better than negative. So I go plus 4h, and plus 4h, and my 4h's show up on the right-hand side. My 4h's are only on the right-hand side. My right-hand side can only contain the 4h's. Watch what this does. This negative 21 can't stay here. It's on the side where the h's go. It's got to go out with plus 21 each. This is gone. 21 minus 5. 11 minus 5 is 6. You can give it 5 more to get to 6. And then 1 from the 10 that was sitting there, 16. 4h equals 16. Our job now is to get rid of the coefficient. Divide by 4. This is h. 1 over 1 with an h. 16 over 4 is 4 over 1. H equals 4. So we'll see if that works. We've got 6 times the number. Number's thought to be 4. Minus 5. Minus 10 times the number, which is thought to be 4. And I'll put in my plus negative 5, my plus negative 10. So we have 24 plus negative 5 plus negative 40. These two are negative. 24 plus negative 45. They add together to get 45 on the negatives. 45 minus 24 is going to equal 21. So I do get 21 from that subtraction, strong on the negative. And the target that this had the whole time was negative 21. It was a fixed target. H is 4. If you work on these processes of getting it so the most we have is one variable term and one number term on each side, then get rid of the worst bank balance for x. You'll have a positive coefficient for x and a number on the other side to do division with. And a positive coefficient is far less risky. So I do encourage people to stick with that kind of work. Here come parentheses. 8 is negative 5 times 3p plus 3p minus 2 equals 90. The target is 90, but right now I've got parentheses to deal with. Got negative 5 times 3p dash 2 equals 90. Yes. So I'm going to insert a plus sign from the minus 2. I'm going to do negative 5 times 3 with a p, negative 15p. Negative 5 times negative 2 gets me positive. 5 times 2 gets me 10 equals 80. So now the only p that I have here is negative, and I'd like that to be positive. So I'm going to go with the plus 08, the plus OP here. There's a p term and a number term here, only a number term here, so I'm going to put plus 0p. I'm going to get after that this way. I don't mind 0p, but I don't like negative 15p, so I add 15p to each side. This is gone. This is 15p, because it added to 0. There were no p's over there. It's okay. Now, this 80 cannot stay. The 15 p's, the p's have grabbed the right side. 80 can't stay here. Negative 80, negative 80. 10 minus 80, they work this way. 70, 80 minus 10. I get a 70, strong on the negative, and now I have to divide each side by 15. So that is a fraction, because if it was 75 over 15, I'd get a 5. If it was 60 over 15, I'd get a 4, but that's some kind of fraction. And I don't want it to stay with negative 70 over 15. I want to take 15, which is the smallest of the numbers, of the two that I have. 15 divides by 1, 3, 5, and 15, and it does not have the 70 divided by 15. 70 divided by 15 will miss because it works for 60 and it works for 75, but it does not work for 70. 70 divided by 5, we can pursue. 5 into 70, we got 1, we get 5, 2 becomes 20, we get 14. So that equals 14, and it turns out that 5 is the number we can divide each one by. So we have p equals negative 70 divided by 5 and 15 divided by 5. We know that 70 divided by 5 not only works, but is 14, so we get negative 14 over 5. Sorry, 14 over 3. Sorry. Let's see. I made a mistake. It's a problem I can trace. And you may have been wondering, where did that 80 come from? This is supposed to have been 90. I'm going to change that 80 to the 90 it's supposed to be. Which then means when I subtracted it off both sides, I was going to subtract off 90. And you can trace it because I'm doing it in purple. 90, 90. Instead of getting negative 70, we would get negative 80. And instead of getting negative 14 when we did our reduction, we would get negative 16 over 3. This is an 80. This is an 80 instead of a 70. It still works to the same concept of 80 divided by 50 doesn't work. 80 divided by 5 will get me 1, 5, get me 3 for 30, get me 6, 30, 0. Okay, negative 16 over 3. So, in order to check number 8, I need some space to work on fractions. If you have a fraction calculator, you can enter every occurrence of a fraction that is negative 16 over 3 as negative 16 ABC3. Depending upon your calculator will determine which way you get that negative 16 in there. Some calculators insist that you hit a dash with parentheses around it before the 16 goes in. Others will say, put the 16 in, then hit me with the plus minus key to switch it up to negative. But 16 ABC5. Here's what I have to do. I have to do negative 5 times 3. My p is going in there, minus 2, and close. Now the number that's going in there is negative 16 over 3. Now, when I multiply this out, you'll see that I got the negative 5 hanging out there, and these 3's will cancel. I'll get negative 48 over 3, or negative 16 minus 2. So those parentheses still need to be dealt with, so I've got negative 5 times negative 18. Let's see. Negative 5 times 3 times my p of negative, I got 16 over 3, right? Yes. Negative 5 times negative 18, that's double negative, the opposite of negative. Two negatives will soon be positive. 5 times 18 gets me 40. 4 out here. 5 times 1 is 5. Get me to 90. So the opposite of negative 90, that's 90. And this was asking it to equal 90 as its target anyway. So yes, can have a fraction. It can be negative, and it can still work out. Now I should look at that when we try to enter these numbers into your fraction calculator. We should be able to show a lot of what the fraction calculator does with computing. It's not a fraction algebrator. I have said that for years. It doesn't do the algebra for you. It does the calculations for you. It can handle fractions if you know how to properly use it. I'm not talking about a $120 calculator from Texas Instruments. I'm talking about a $7 calculator, maybe a $20 calculator with a TAN key that has the ABC key on it. So before you buy a calculator, you want to make sure that it has the ability to handle fractions. Normally, I have people buy their calculator, bring it to class, and show me the calculator while it's still in the package, in case they bought one that's not doing what we need it to do, and I'll say, take it back, look for this. Most of the time it has what they want, but I'll say, there's your ABC key, they'll open it then, because they want to return it if it's not right, and they want it still sealed. We'll do the same thing. Why don't you buy your calculator, look for the ABC key, and then before you use it for the first time, jump into one of my 6-hour office opportunities for you to come in and hold it up to your computer so that I can see it, say, yes, that's the one, that's the key. We can even work through it for 5 or 10 minutes and show how to work it. But don't open your calculator until you know it's the right kind, and don't spend over $20 on it. But I think that ABC key has saved a lot of students from difficulties with fractions to allow them to still continue to do algebra and move on with greater success in other fields. Okay, let's try this one. 6 times 3x plus 2 minus 6 equals 4. Now over there equals 4, we've actually got a target for this one. So let's see what we got here. 6 times 3x plus 2 plus negative 6, that equals 4. Then we'll multiply the 6 by 3 for 18x, plus the 6 times 2 for 12, plus negative 6, still equals 4. Now this is where we have to make sure, and this is a step, because people like to do the crossing out of these opposites and all that kind of thing, that they get too excited about that. We don't do that until after we've combined like terms. 18x plus 12 plus negative 6. Negative 6 is a number like the 12. That's just 4, so it gets to stay that way. This is 18x unchanged plus 12 minus 6, which is going to get me 6, and that equals 4. Now the 18x is good where it is as a positive value compared to 0x's, so I'm now going to subtract 6x off each side. That's gone. 18x equals 4 plus negative 6. Take the 6 and the 4, subtract them from working against each other, you get a 2. Strong on the negative. Let's divide each side by 18. So now x is equal to negative 2 over 18. Each top and bottom divide by 2, because they're both even. Negative 1/9. Take that and we'll check it out. We have 6, and then 3, and here's where my number goes, plus 2, then minus 6. My number, plus when is negative 1/9. In parentheses. So, we've got 6. In the parentheses, we have 3 times negative, we can cancel 3 and the 9 down to a 1 and a 3. But what that makes is 1 times negative 1 for negative 1, 1 times 3 for 3, plus 2, then minus 6. This is 6 times negative 1/3 plus the 2 is over 1, triple that, triple that. This is how we add fractions. We have to triple the 1 to make 3, triple the 2 to make 6, and then minus 6. This is 6 times negative 1 plus 6 all over 3, then minus 6. This is 6 times 5 over 3, then minus 6. 6 and 3 will reduce to 2 and 1. 2 times 6 is going to get me 10. 2 times 5 is going to get me 10 over 1 minus 6. That's 10 over, 10 over 1 is just 10. 10 minus 6, that finally equals 4. Now what was it supposed to equal the whole time? 4. It does the job. Answer here was x equals negative 1/9. It did work. Fractions work, negatives work, even negative fractions can work. There's only one number that makes both sides equal, and they both equal 4. So those 8 and 9 are really strong indicators of why people might want to get their hands on and regularly use a fraction calculator for this work. Dedicate the time that you use to thinking and working in algebra, and knowing your calculator can do that strong work. I hear young people all the time, I'm old myself, but I hear people saying, well, we have technology, we have these great calculators with us all the time. I agree. I don't need you to become the world's greatest hand doing of adding fractions with positives and negatives and unmatched denominators. I need you to know how to use the technology you have to solve the problems that present themselves to you. And a problem right now might be working with fractions. The technological answer costs between $7 and $20, and you can then show all the skills you've learned in manipulating your way through the algebra and the thinking about what to do before it's done. You don't want to get yourself in a tight spot and say, oh no, what do I do? And then blame bad luck or a teacher that gave you a bad problem. So that calculator is going to be part of your decision making outside the class that may affect your outcomes inside the class. Number 10. 5 times 1 plus x is supposed to equal 2 times 2x minus 2, which is in parentheses, and then minus 10. Now what I see there is 5 times 1 plus an x, and I need a 1 in front of that x, so I have something to multiply my 5 by. You can multiply 5 by x, but 5 by 1 is more like what we would do in general. 2 parentheses 2x plus negative 2. And then the minus 10 will become, of course, plus negative 10. And there are two sides to that. 5 times 1 is 5 with no x, plus 5 times 1 with an x is 5x, equals. We have here 2 times 2 with an x, that's 4x. We have 2 times that, negative 2, so plus negative 4, plus negative 10. There we got rid of the parentheses through distributing until the end of each pair of parentheses. Next, we look at each side and we determine if there are any like terms to be dealt with. 5 plus 5x, no like terms. 4x minus 4 plus negative 10, these are like terms. Negative 10 right there, here we go. 5 plus 5x stays unchanged, equals 4x plus, we have negative 4 plus negative 10, working together, 10 and 4 will get me digits of 14. So I write my 14. I look at my two added numbers, 10 is stronger in negative, there I have it. If you look at what I've gotten, here the parentheses are gone, step 1. Combining of like terms on each side, even though it was only the left side that needed it and it only needed it once, that's an important step. I'm now looking to get rid of the worst bank balance. I have a 5x and a 4x. 4 is worse than 5, so I'm going to get rid of 4x. I'm going minus 4x minus 4x. That's gone. This is 1x. In this case, my x's can only be on the left side. Okay, now that I've done that. And only my x's can be on the left side. So divide 5, minus 5, minus 5, right, plus negative 5. This is gone. That creates negative 14 plus negative 5. That's a 14 and 5 working together to get 19. So this is going to equal some kind of 19. Strong term is negative, so my answer will be negative, even if you want to divide by 1, right? X equals negative 19. So let's go up here and see what happens. 5 times 1 plus my 19, it's negative. So my negative 19 in parentheses, and my red 1 to free it from the parentheses. I find it easier to free it from the parentheses as necessary than to say, do I need parentheses now or is it minus 19? I do that every time, and I can quickly use the 1 to free it up and then go on with the work. So we got 5 times 1 plus negative 19. 5 times 19 and 1, subtracting get me 18. So we got an 18 strong on the negative. 5 times 18, 0, there's the 4 from 40. 5 from that, and I get 90. I'm going to get negative 90. That's one of them. Now this guy, 2 parentheses 2 times my number. My number is negative 19. Close it. Okay. Minus 2, close parentheses, and minus 10. So we have 2 times 19 times 2 is 38 with a negative. Negative 38 plus negative 2, then minus 10. 2 times 38 and 2 makes 40, strong on the negative, so negative 40 minus 10. And I have 2 times 40 is 80 with a single negative, plus I have a negative 10. Add those together, 80 and 10 make 90, strong on the negative, and they do hit the same target. So that's good to go. The answer that got me here was this number, x is negative 19. Number 10 is done. And what's happening when I check it into the original equation, I am confirming that it is the only number, once fully reduced, that exists in all of everything that's going to do the job. Every other number is going to be either too high or too low for the target. The targets will not hit each other, will not meet each other at the same place. They could be close, they could look similar, but they will not hit each other to the spot that we need to for where they're going, unless the solution is x is negative 19. Number 11. 2 parentheses 4 t dash 4 plus 12 equals 6 parentheses t dash 2 dash parentheses negative t dash 3. Okay. 2 times the 4 will get me 8. Well, I should write it again. Right. 2 times 4 t dash 4 plus 12 equals 6 t dash 2 dash open dash t minus t dash 3. I got some 1s and pluses to put in here to get to work. 2 parentheses 4t plus negative 4 instead of minus 4 plus 12 equals 6. There's a plain old t, so I'm going to put that as 1t plus instead of plus negative 2 instead of minus 2 plus instead of minus, I have plus negative. Here comes the rest of that. 1 behind that. Squeeze a 1 in between that dash and the t. I mean, it is still negative, but better to have it as negative 1t. And a plus sign in front of the minus 3, so it can be plus negative 3. Now I can get after the distributing. That was just setting up the pluses and the 1s. 2 times 4 with a t, 8t. Plus 2 times 4 with a negative, negative 8. Plus 12. I am going to finish off this side before I go over to that side. 8t plus negative 8 plus 12. This 12 matches this 8, both are numbers, so I'm going to put in 12. And this is going to get me 8t unchanged. 12 minus 8 gets me plus 4, strong on the positive. Now I'll work on the other side. And I won't worry about this anymore until they're both done and we have what I call a full house, which is a t term and a number term on each side. Here we go. Equals 6 times 1 with a t, 6t, plus 6 times 2 with 1 negative, negative 12, plus negative 1 times negative 1. 1 times 1 gets me the 1. 2 dashes is going to get me 1t positive. And now negative 1 times negative 3. 1 times 3 is getting me 3, but negative 1 times negative 3, that's 2 dashes, causing it to be a positive 3. Now this, locking what happened over there. First t, first number, second t, second number. 6t minus 12, then the 1t joins the 6t, and the 3 goes under the negative 12. Let's see what we've got. 6 plus 1 is 7 in the t column. Negative 12 plus 3 is 12 minus 3 gets me 9, strong on the negative. So I gotta make sure I know that's negative. But there we go. This is 8t plus 4 and 7t minus 9. I'll stop and ask you to think, or you can stop the video to see. Here we are. Which is worse, 8t or 7t? To me, 7t is worse. It's not as good as 8t. I'm getting rid of 7t. So I go to the 7t, I subtract 7t. I come over here, I subtract 7t. That's gone on the right and 1t on the left. 1t, awesome, because now I won't have to divide by my coefficient later on. T's are on the left. T's are only on the left, and only t's can be on the left. Goodbye. 4. Positive 4 needs negative 4 to get rid of it. This is gone. A really long equal sign if you want. Negative 9 plus negative 4. 9 and 4 work together by adding to get 13. But they're strong on the negative. I can divide by 1 if you want to see it. A t equals negative 13. Did that work? I'm going to find out. 2 times 4. My number's going in is negative 13. That's my t. Minus 4, close parentheses, and plus 12. This is 2 times negative 52 minus 4, which I'm going to put a plus in front of my old minus 4, then plus 12. This is 2 times, that makes negative 56, plus 12. That multiplies to get me negative 112 plus 12. So I have 112 minus 12, and I get 100. But it's strong on the negative, so that's negative 100. So negative 13 goes in the left side, creates the value of negative 100. 6, here comes my value, negative 13, my value for t, minus 2, close, minus the opposite of my number, negative 13, minus 3, and close those parentheses. So this is now getting me 6 times negative 13 plus negative 2, which is 6 times negative 15, which gets me negative 90. But back here, I have plus I have negative 1. And in the parentheses, I have the opposite of negative 13, so I have 13, plus negative 3. So what do I have back here? I have plus negative 1 times 10. I have plus negative 10. 90 plus 10 make 100. Strong on the negative like the 90. They each make negative 100. That is correct. The answer for this, as t equals negative 13, is correct. That's without a calculator. If you have the calculator and use it to your advantage, you can much more easily put in, now that you know you got negative 13, 2 times parentheses 4 times negative 13 minus 4 close parentheses plus 12 equals. It will get you negative 100. Then on your calculator you would go 6 times parentheses negative 100 minus 2 close parentheses minus open parentheses negative sign in front of your negative 13 minus 3 close parentheses equals. It'll get you negative 100. So the calculator can do this stuff, but you have to have skills and confidence. Okay? The skills with the calculator are not as hard to master as, for example, the skills of doing this on paper. The confidence can come from success through successfully working with your calculator to see what you're doing. It's not blindly punching keys, but knowing what they do and having them do the job for you, right? We no longer walk to campus, most of us, a few of us do, but we've got cars. Some of us have Uber, some take the bus. We have things that technology does, and we shouldn't have people trying to convince us that the only way that life is worth living is if you walk to your college campus. That doesn't make sense to me. Technology is a wonderful thing, but we need to use it, we need to know how to use it as well. So we're going to go for 12. 2 minus 3, then parentheses x plus 2, close, and that's supposed to equal a fixed target of negative 16. 2 dash 3, parentheses around x plus 2, then that equals dash 16. I have no worries on the right-hand side. There's no parentheses, there's no like terms. The target here is actually locked up. Negative 16. Let's see. I need to put a plus in there, 2 plus negative 3. That cuts the negative 3 away from 2 minus 3 and cuts it into its own terms, so the negative 3 can be distributed. 1 in front of x will help as well. 2 stays alone, plus negative 3 times 1 with an x, negative 3 times 1 is 3 with a negative and has an x, plus negative 3 times 2. That's a single negative. 3 times 2 is 6. And over here we still have negative 16, and I'm not worried about that anymore. Not right now. We got this to deal with. 2 plus negative 3x plus negative 6. The first and third one were numbers. I'm going to take my negative 6 over here, put it in the column where it belongs, with the 2. I'm going to add those two values. 2 minus 6. 6 minus 2 gets you 4. Strong on the negative, you get negative 4 plus 3x. This has been used in another column. Then we hit our equal sign and we have negative 16. 3x is good and positive. I don't have any x's there. I can leave it like that, because now what I'm going to do is I'm going to take my negative 4 plus 3x equals negative 16, and I'm going to get rid of the negative 4 by adding 4 to both sides. That's gone, leaving nothing but 3x on the left. I want 3x on one side, and nothing but negative 16 plus 4, they work against each other, giving me 12. Strong on the negative. I'll divide each side by 3. X is a negative value. 12 over 3 gets me 4. X is negative 4. That's what I think my value is. When I go back up here, 2 times my number, 2 minus 3 times my number plus 2. And it's supposed to equal negative 16 when we're done. My number's going in as negative 4. Now it's in parentheses, so of course I've got the 1 here, but that's okay. It will be freed up very soon. 2 plus negative 3, and we're ready. 2 plus negative 3 times negative 4 plus 2. Those parentheses need to be done, so 2 plus negative 3 times, subtract for 2, strong on the negative, 2. Well, now that didn't seem to work. Let me just see. Well, let me finish it out and show you how maybe it doesn't hit what I think it's going to hit. Because here I've got 2 plus negative 3 times my number plus 2. My number seems to be negative 4. And I think I've got a conflict here in that my checking it isn't going to hit 16. Let's see what happens. 2, negative 3, that makes negative 2. That's going to make 6, and I get negative 4 here. Uh-oh, something didn't go right. I might have checked it wrong. So I'm going to take a look at that now. 2 minus 3 times negative 4 plus 2. Therefore, negative 4 plus 2 becomes negative 2. Negative 3 times 2, 6. And so 6 plus 2 gets me 8. That's not right. So that makes me think the negative 4 is probably not perfect. And so you've seen that there was value in checking it. Now let me check my problem as it will go. All right, let's see what happened here. You know, some people will say I dropped the negative. That's what I would have to say right here. Plus negative 3. Okay? So that's where I'm going to change up the way I did it and have it work so I don't have to divide by a negative. I want to stick to the process that I went through. I dropped the negative, and if you do that, it's likely to go wrong in one way or another. Unless you're lucky enough to have 0 show up pretty soon, dropping a negative is going to cause some difficulties. Here's where we are. The corrected format. I'm going to pick it up in purple the rest of the way. Now I have negative 3x, and no x is over here. That's 0x. That means I prefer 0x. I've got to get rid of the 3x. I'm going to go plus 3x plus 3x. This is gone, and this will put the 3x on the right-hand side where there were no x's previously. Let me see if I have a better working purple. This one's been getting a bit of a workout, which is kind of sad. Okay. So the 3x's are on the right. X is only on the right. Only x is on the right. Goodbye, 16. Plus 16 plus 16. 12 over here equals long. Divide by 3. Divide by 3. X is 4. Positive. All right, let's see how positive 4 wants to work. 2 minus 3 times my number plus 2 is supposed to equal negative 16. Question. My number wants to go in here as positive 4 with parentheses. Turns out I don't need the parentheses, so the 1 will set me free, the one that's coming along in front. And now I have 2 plus negative 3 times 4 plus 2, 2 plus negative, let's see, we got the opposite. We got 4 plus 2, okay. Did it happen again? Ugh. No, it's gonna work. 2 plus negative 3. I guess confidence can take a hit every once in a while. 2 plus negative 18, subtract for 16, strong on the negative. And now that I've made my adjustment, it did work. And my correct answer is x equals positive 4. Not only does it happen to the best of us, it happens to me also. Got a mistake in there. I own it. I put the purple. I don't claim to be flawless. That makes life easier to get through every day. And when I make a mistake, I'll admit it, because I don't want you to think that what I did wrong is correct. When I went from here, negative 3, somehow it became positive with no good cause and no excuses. That's why the purple is out, the purple marker of shame. And a really bad sign is when the purple marker of shame starts running out of ink, because that means there's been a lot of shame through the years. I mean, it's not like I bought that to start the semester, to be real, but still. Number 13. These are not numbered perfectly with everything in the homework, but they are very close. There'll be 1 or 2 numbers off, and you'll find a very similar problem assigned to you in the homework. 4, parentheses, n plus 1, minus 3 equals 3n plus 4. This one looks like it almost took a little bit of an easier time of it. We'll see, because it's not quite as aggressive as the other ones. Maybe a little. 4, parentheses, n plus 1, dash 3 equals 3n plus 4. Alright. I got a plus negative 3 instead of minus 3. I got a 1 in front of my n. Those are the only real additions I needed to make here. 4 times 1 with an n, 4n. Plus 4 times 1 is 4, plus negative 3. Now we cover up the other one. We're not even looking over there until we get done combining our like terms. We should only have 2 terms over here at the most. And that's true. 4n plus 4 minus 3. Negative 3 goes under the 4. 4n plus 1. And over there we have 3n plus 4, which didn't change. It's good. It's got a single n and a single number, so 3n plus 4, right, equals 3n plus 4, it stays that way, and here we are. Okay, my thought about which ends to get rid of the worst bank balance. It's not because who's on the left or right, but 3n is not as good as 4n for bank balance. I'm going to subtract 3n. Gone. 1n shows up on the left. That 1 on the left can't stay as a number. Okay, this is gone. Remember, you're going to have a scratch out on each side when it works in the normal way without anything canceling completely to 0 on both sides. This is now why I've been able to scratch out the 3n on the left with negative 3n and the positive 1 on the right with a negative 1 going in, and here we go. 4 minus 1, 4 plus negative 1, that's 3. Divide by 1 if you want, because maybe you're used to it, n equals 3. 3 is my number here. I said it looked like it might be a little easier. It just didn't have all the big buildup that some of the other ones did. We're going for 4 times my number plus 1 minus 3. In for my number is supposed to go 3, which I put in parentheses, and when it's in there, with nothing else, I put a 1 in front of it to free it from the parentheses around, the blue parentheses around the 3. This is 4 times 3 plus 1, then minus 3. This is 4 times 4, then minus 3. This is 16 plus negative 3. This is 13. Ooh, ominous. Not a very lucky number. Let's see what happens. Over here, we've got 3 times my number plus 4. My number goes in with parentheses, so it does not look like 33. Not that there's anything wrong with that. 3 times 3 is 9 plus 4. Right, Larry Bird, right? 13. Okay. That did hit it. N equals 3. It's going to do the job. There are two things going on with numbers here. One is find the solution. Number 2, make sure both sides hit the same value. The solution is the key that makes them match. The solution is known to be right when they match. So it's kind of weird. The solution only has value when it gets them to match, but they can't match until you get the solution. Something's got to be first. Aha, distributing a negative. Big risk for some people is the loss of the negative when you're distributing. We have 2-4 parentheses 4x-4 close equals a fixed target of negative 7. (2-4 parentheses 4x-4 equals negative 7. I don't need any 1s here, but I do need to put a plus negative 4 there and a plus negative 4 there for a pair of occurrences of pure subtraction or pure minus. 2 plus negative 4 times 4 with an x, negative 16 with an x. Negative 4 times negative 4. That's 4 times 4 for 16. A negative and a negative, it is 2 dashes to make it be positive. It does not have an odd number of dashes, which would have made it negative. That equals negative 7. I still think this is one of the most important steps that people come across. The step here is when we cover up what's on one side of the equals and we look at that and we say, are those like terms all taken care of? They are not. I'm going to take this 16, bring it over here as its own 16. This is the combining of like terms where it stays itself. We're not attempting to cancel anything out right now. We have 18 plus negative 16x equals, all that's there is negative 7. Now we can see why this one might be a little bit tough to get through, because when we go for what this needs me to do, I need to get the negative 16x. I can isolate that, or I can say, I don't like negative 16x, I'm going to add 0x to this side and get it going, like this. Negative 16 or 0, 0 is actually better. It's not an awesome bank balance, but it sure beats being $16 million in debt. Plus 16x, plus 16x. That's gone, we got 16x over here. Now, 16x is on the right side, x's can only be on the right side, only x's can be on the right side, which is why we do plus 7, and we get 25. That's out. Long equals, divide by 16, divide by 16, x equals 25 over 16. That's what I think my answer is. All right. Let's find out if it works. 2 minus 4 times 4 times my number minus 4 and close it. Luckily the other side is already locked up as negative 7. So I don't have to chase this 25 over 16 all over the place. But it's some work. If you have a fraction calculator, you can do 2 minus 4 times, open parentheses, 4 times 25, ABC key, 16, minus 4, close parentheses, equals, and it should hit negative 7. I'm about to see why that is. 2 minus 4 times 4 over 1 times 25 over 16, then minus 4, which is 2 minus 4. Divide by 4 for 1, divide by 4 for 4. 25 over 4 minus 4, which is 2 minus 4 times 25 over 4. That 4 is over 1. We multiply top and bottom by 4. 4 over 1. 4 times 4 on top is minus 16. And 1 times 4 on the bottom is 4. So we have 2 minus 4 times 25 minus 16 all over 4. And that's, let's do this. 2 minus 4 over 1 times 9 over 4. The 4's will cancel. Doesn't it sound good to have that calculator now? 2 minus 9 over 1, 2 minus 9, 2 plus negative 9, subtracting at 7, strong on the negative, and look how far I have to go to find that it did hit the target, and the perfect and only answer for this equation is 25 over 16. The process does not change, the numbers do. And if there's a fraction involved, or more than one, then the computation on a computer, or the calculation on a calculator will change. They've had calculators for a long time. Some of you may know what calculators were like during World War II. And in the 1960s in the NASA program. A lot of the calculators were people. A lot of the people were women. They called them calculators because their job was to complete calculations, but they were people. And they trusted them more than the machines in the early days of digital computing. 15. 15 is this, 6. This one has a tricky answer. Times 3w plus 2 minus 3 equals 18 times w minus 1 plus 27. And we are looking for the situations where w makes both sides equal. Both sides of this, when I use a specific value of w, will get the same number. So I have 6 times 3w plus 2. I do put a plus sign in front of my minus 3, so it becomes plus negative 3, and that will help with the like terms. Let's get that done. 6 times 3 is 18 with a w, plus 6 times 2 is 12, plus negative 3. Now when we look, we're not doing that yet. We're over here, 12 plus negative 3. I'm going to take the negative 3 and join it into the column with the 12. 18w plus 9. 12 minus 3 straight to 9, positive. Over here, we have to put a 1 in. We have 18 times 1 in front of my w. Right there, that w. Plus a negative 1. And then plus 27. And what happens here is 18 times 1 will get you 18w, plus 18 times 1 with a negative will get you negative 18, plus 27 that was already done and out there. This has like terms. I cover up this, 18w plus negative 18 plus 27. We'll add 27 to both sides. We've got 18w that doesn't change, and here we've got 27 minus 18. Do the subtraction, turn it into 17 minus 8, 2 more, that's a 9. That's plus 9. 18W plus 9 equals 18W plus 9. Here we are. It seems weird. It's unusual as it's not like the rest of them we've done, but we're going to run with the concept that I said, get rid of the worst bank balance. If the bank balances are equal, then they're both the best and they're both the worst. 18W is the worst bank balance. It happens to be a tie. It's a tie for worst, it's a tie for best. 18s are both going out, so I'm going to subtract my 18W off each side. And something weird happens when that occurs, and we'll just see what that is. These are gone. Okay, so now I can't have numbers on both sides, so I'm going to say, let me get rid of one of these numbers. Let me subtract 9 here. So I'm going to have to subtract 9 off both sides, and this gets me 0, and that gets me 0. And so, when we finished problem 13, we said the only time this equation works is anytime n equals 3. 14, the only time that equation works is anytime x equals 25 over 16. And this says the only time this equation works is whenever 0 equals 0. And so I call this a sometimes answer. Answers can be always, sometimes, or never. And if we find the one time that it works, it's sometimes. It works when it's 3, not any other time. It works when it's 25 over 16, not over any other time. That's sometimes. So when does 0 equal 0? And your answers are sometimes 0 equals 0, always 0 equals 0, or never 0 equals 0. And 0 equals 0 always. So any number will work. This is called, the solution is all real numbers. However, if you do the work out and you get a situation where it says 0 equals 10, 0 never equals 10. And that would be never, and there'd be no number that works. This is a case where every number works, which means I hope your lucky number is a small one, because if you do this problem with your lucky number going in for W, it should hit the same target on both sides. If you're watching this video and looking for extra credit, go ahead and tell me what your lucky number is, an integer between 1 and 100, positives only. I hope no one has a negative lucky number. Hopefully it's kind of small. Tell me what your lucky number is, do out the work on both sides, and tell me what target it hits for your lucky number. It should hit the same number on both sides. If it works out, send me an email telling me what number you put in and what target both sides hit. And thank you for watching the homework thus far so you can find out about it. Now, if everybody keeps sending me the same lucky number and the same target, then I'll know word's getting around and only the first person will get it. So if your lucky number is 7 and somebody else already sent in 7 with the target, I'll send it back and say, what's your second luckiest number? But there is extra credit available for this. What I'll do for extra credit is I will take your worst homework score for the semester and replace it with 100. We'll have to wait till the end of the semester, but that means that if you got a 0 on a homework, it can immediately become 100 because you did this extra credit. So think about it. All right, that's 15. As I turn the page, let me see if I have anything more. I have one more problem. As I told you, I'm doing almost all the problems of this assignment because it's got so many details that just are best examined by doing problems and repeating the process. The process is really those 7 steps. Getting through the steps can be a challenge, but there's no problem that needs something other than those 7 steps to get our work done and this equation solved. All right, let's see what I got here. Number 16 of the ones I'm doing. 9 minus parentheses around 3p plus 3p. Wow, must be getting tired. It's been a long homework problem set, but let's go. 9 minus 3p plus 5, close, equals 8 minus p. Doesn't look as long or nasty as some of the ones we've seen. I wonder what kind of answer it's going to have. Well, let's see. 9 dash parentheses 3p plus 5, close, equals 8 dash p. In front of the p, between the dash and the p, I'm putting a 1. Behind, in front of those parentheses, I'm putting a 1 between the dash and the parentheses. 9 plus -1 instead of minus. 8 plus -1 instead of minus. Okay, we're pretty ready to go here. 9 plus -1 times 3, -3 with a p, plus -1 times 5, -5 equals. 8 is unchanged, plus -1p is there. Now we look for our like terms. We should always come up after the parentheses are gone to look for like terms. 9, -3p, -5. -5 joins the numbers like 9. 8 plus -1p, no like terms on that side. This is 4. 9 plus -5 is 4, plus -3p. Over here, we have 8 plus -1p. I am so excited. This is a great example to wrap up with because of what it does with the worst bank balance. -$3 million is worse than -$1 million, even though both are bad. We're going to get rid of the -3p. We're going to go plus 3p. The -3p and plus 3p is gone from the left, and the right side gets 2p. That 8 cannot stay because the process is, once the p's have established the right side, my p's can only go on the right side in this one, and only my p's can go on the right side. This 8 cannot stay. Dash 8, dash 8. Right, we're going to add them, and this is gone. 4 plus -8, subtract them for 4. Right, 8 minus 4 is 4. Strong on the negative, and then can draw a wide equal sign if you want. Divide each side by 2. It looks like -2 equals p, so p equals -2 is what I'm going with. Oh, good. -2 might not be even all that bad to check with. -2 every time p occurs. 9 minus parentheses 3. Oh, don't write p. I'm going to get my -2 in there. Plus 5. Closed. And that's supposed to equal 8 minus, and my number is supposed to go there. My number is -2. Here. Here. The -2 over there behind the 8 minus needs a 1. I'm still comfortable having the plus signs in front of my negative terms. Here we go. Let's get the first one, see the target. Let's see if the other side hits it. If it hits it, we're done with this assignment. 9 plus negative parentheses. 3 times 2 with a negative. -6 plus 5. 9 plus the opposite of -1. Oh, I forgot there's 1 here, huh? Why did I do that? Let me put this 1 here, this 1 there. I had it before. This 1 there. Okay, what we have now is 9 plus opposite of negative, right? 2 dashes, that's a positive. 1 times 1 is 1, I get 10. 10 is my target. If I get 10 on the other side, we're done with it right. 8 plus the opposite, we have 2 negatives on 2, that's 8. Checking it, equals 8 plus the opposite of -2 is 2. We got 10. They hit each other. Woo, we did it. I don't know how many of you are here for the whole thing, but I'm telling you, that was quite a workout. But that's how we solve equations. It's a very important section. The homework section of this is as demonstrative as the lecture section, because the lecture section laid the groundwork for those rules, and the 16 examples that we did here did a very strong job of covering the content of how to get through this process. So I expect to be helping people a lot to get through it, because it can be complicated, but if you master this process, they really can't throw too much at you that's going to be like, oh no, I can't do that one, because we're ready for it. All right, good luck with this.